Hello students, we will discuss now paper 2, JEE Advanced 2024 paper, chemistry paper. So let us start. Again, only one option correct type. According to the Bohr model, the highest kinetic energy is associated with electron in. So as we know, the kinetic energy is, with the magnitude wise, it is equivalent to the energy of the orbit. But kinetic energy is positive, total energy will be negative. So that total energy of electron in an orbit is nothing but it is minus of this will be your kinetic energy. So what is energy of electron in an orbit is 13.6 into, because anyhow minus was there, that is really z square by n square. Okay. So for the Bohr first orbit, so the first one, first orbit of hydrogen, it will be 13.6 only, electron volts. Next, first orbit of helium plus, so first orbit of helium plus will be 13.6 into 4. Next, second orbit of helium plus by 9 will by 4 will come, so anyhow it will become 13, second orbit, no? Okay, z square will remain same. So it is second orbit will be less, as we even know electron moves away from the nucleus. Already in first paper it was there an option. As it moves away, speed of electron will decrease, kinetic energy will decrease. Second orbit of lithium 2 plus, second orbit of lithium 2 plus. So it is 13.6 into 3 square 9 by 4. So anyhow it will be the highest. So that it is first orbit of helium plus. Okay? Then metal deficiency oxide is formed, has a formula of Mx and Y2O4. Metal has plus 2 and plus 3, M has plus 2 and plus 3, both M and Y are metals. Then oxidation state, Y has only plus 3. If the fraction of M plus 2 ions is 1 by 3, what is the value of X? So this is again based on the oxidation state when you do it. So when you have Mx, Y2 and O3, oxygen is anyhow minus 2 oxidation state. He said it is plus 3, but it may be having plus 2 and plus 3. So it is like we just say non-stoichiometric type oxide. So the oxidation state or the total charge that should be there on this will be now. This is plus 6, this is minus 4, minus 6. So this is overall charge is minus 6. Sorry, O4, not O3. So overall charge is minus 8. Here plus 6. So this has to be the overall charge on this will be plus 2. So if M plus 2 fraction is 1 by 3rd, what is the value of X? So the overall charge will like say average charge. So that plus 2 charge is there and it has X amount of M is X. 1/3 of that is X by 3. Plus 3 charge is there. If the fraction of M plus 2 is 1 by 3rd, the other one should be 2/3 only. So that it is 2x by 3. Overall value should be equal to plus 2. Okay. So what is x? So this is 2x by 3, this is 6x. Clear? 2x by 3 plus 6x by 3 is equal to plus 2. That means it is 6. So this is nothing but 8x is equal to 12. So x is equal to so this is 6 only, no? 6x by 3, 2x by 3 is equal to overall value should be equal to plus 2. So where we are going, this is 8x, this is 6, sorry. This is 2, so this is 6 only. So fraction you should not get. So 6 by 8 means 3 by 4. So 0.7. So this will be the points. Okay. Next. L-glucose on reaction with HI, then chromium oxide, 10 to 20 atmosphere pressure, Cl2. Direct question, actually based on that. D-glucose or L-glucose, the characteristic reaction with HI is, they will convert into N-hexane. So L-glucose will give, or D-glucose both will give. Reaction with HI will give N-hexane. Then N-hexane, when treated with chromium oxide, aluminum oxide is aromatization reaction, will form benzene. Then benzene treated with chlorine in presence of light with excess. So already this reaction is there directly in NCERT, forms hexachloro, Cl here, Cl here, Cl here. All carbons will be addition of chlorine takes place. Okay? Pi bond breaks. You will see the chlorine will be there at all places. Okay? So this is the D option. We are not able to see. Okay? Directly it is there in NCERT even. This reaction itself. Next. This is beyond our NCERT level question, actually an inorganic. Fluorination of phosphorus pentachloride in polar solvents. So, the polar solvent fluorination may be PCl5 actually exists as PCl4 plus and PCl6 minus. So the fluorination mainly taking place in the octahedral complexes and it forms isomers. So where you generally see the isomer size, you will see this compound where octahedral complex is replaced, you will see isomers you will exist. Okay? So that this is the possible. Means this can show isomerism. So that is conceptual. You have to know this because it is beyond our NCERT books. Next. More than one option type. This is also not there in NCERT again, which is little bit beyond, but if you just try to do it logically, little bit can be done. That is N2H4 is chemically oxidized. So where oxidation takes place in electrolysis process is at anode. So he asked electrochemical reactions will produce N2, where chemical energy will convert into electrical energy. So it is like a fuel cells type process. So N2H hydrazine we are using and oxygen we are passing as fuels. So the first option, let us say choose the correct option in this. OH minus ions react with N2H4 at anode to form N2. That is okay because oxidation takes place and release of 4 electrons. So if you write the reactions, OH minus and like hydrogen and oxygen, what you are actually seeing the same. OH minus will move towards anode and our cathodes, then H plus will move in fuel cells. So first option can be correct. At cathode, it will break into N2. So it cannot break that. Decomposition, it's maybe reduction happens, but this process is not even reduction, this is oxidation. So this cannot be our option. At cathode, molecular oxygen may be converted to, so it is a reduction because oxygen is O2, OH minus oxygen is minus 2. So it's a reduction. So this can be like logical, where anode oxidation takes place, cathode reduction takes place. So if you use that optical applications, maybe these two okay. Then oxides of nitrogen are major byproducts of electrochemical process. But usually the anode and cathode are mainly maintained. Let us say we just try to separate these two products which are formed at anode and cathode. But in a chemical reaction, anode and cathode components can react with one another and can also convert into some byproducts. So maybe this option we can take. If precautions are taken, you don't get any oxides of nitrogen and oxygen. But if precautions are not taken, maybe you can get. So this option again is a doubtful option. But A and C are sure they are correct. So A, C or A, C, D we can consider for this. The next, the options with the correct sequence of reagent to convert. The triple bond we converted to double bond. Ester is converted to acid. Cyanide is converted to aldehyde. This is ester converted to alcohol. This is ketone converted to alcohol. So if you add first, let us say Lindlar's catalyst, triple bond becomes double bond, okay, no problem. But SnCl to HCl will convert this into imines. Sodium borohydride will reduce the ketone but not acid and ester. Clear? Then hydrolysis. Then hydrolysis of ester can happen. Hydrolysis of esters can happen here. Then hydrolysis of imines can happen to form aldehyde. So this can be correct. But maybe there is a possibility that imines can be reduced by sodium borohydrides. Then in that case, you cannot get that. Okay? But already this is reduced, then sodium borohydride can reduce imines. So that one option is there. This is again a doubtful case first. Then next, Lindlar's catalyst with hydrogen. Okay, double bond, triple bonds will convert into double bond, no problem. Hydrolysis, this will be hydrolyzed, this will be hydrolyzed. Clear? Then cyanides can also be hydrolyzed into acid. Then you can't reduce with sodium borohydride to aldehydes. So even SnCl2 cannot be useful. So this cannot be the. So when you hydrolyze it first, ester hydrolyzes, cyanide hydrolyzes, nitrile hydrolyzes. Then sodium borohydride, okay, nitriles will form. SnCl2, sorry, this will convert into alcohol. Nitriles also cannot be. SnCl to HCl, this is into nitrile, hydrolysis, aldehyde, acid and acid, alcohol. Lindlar's catalyst will be done. So this can be done, okay, no problem. So sodium borohydride reduces first ketone into alcohols, then are not affected mainly. Then this will be reducing this into imine. Hydrolysis will give here acid, here aldehyde, here again alcohol. Then Lindlar's catalyst will convert double bond into triple bond into double bonds. So that can be done. Lindlar's catalyst, first triple bond into double bond. Sodium borohydride again first will convert this into again into alcohol. Same, just a small change. Lindlar's catalyst can be used later. So these two are always okay, no problem. This is little bit doubtful case with the imine case with sodium borohydride. Okay. Next. This is the easiest. Little bit again. Peroxide linkage exists. So H2S2O2 is called pyrosulfuric acid. H2S2O8 is called per disulfuric acid or peroxy disulfuric acid. So this will have a peroxy bond. This H2S2O5 is pyrosulfurous acid. So this doesn't have. This will have SOS linkage. This will also have SOS linkage. Then this is per monosulfuric acid. So this will have direct applications are theory based. Directly we have in NCERT itself. Next, non-negative. To form complete monolayer of acetic acid, 1 gram of on 1 gram of charcoal, 100 ml of 0.5 m acetic acid was used. Then some of the acetic acid is remain unabsorbed. Then to neutralize the unabsorbed acetic acid, we used this. So how many millimoles of acetic acid we have taken? That is, because it is given in ml, 100 into 0.5. So we have taken 50. That is unabsorbed acetic acid we neutralized with NaOH. So the number of millimoles of acetic acid unreacted, unabsorbed otherwise, unabsorbed, will be equal to number of millimoles of NaOH what we use, because NaOH and acetic acid will react in 1:1 ratio. So that is 40 into 1, 40. So how many millimoles are adsorbed? Only 10. So millimoles of acetic acid adsorbed. So what you have to calculate totally is, each molecule will occupy P into 10 to the power minus 23 meter square area on the surface of the charcoal. What is the value of P? And he gave the surface area of charcoal as this much for 1 gram. So you have taken only 1 gram of charcoal already. So your total area will be 1.5 into 10 to the power of 2. But number of millimoles what we observed is this much. So let us say how many molecules are there. So let us say molecules of acetic acid. Because for each molecule you have to calculate. So let us see total number of molecules which are adsorbed. That is 10 millimoles into 10 to the power of minus 3 moles into Avogadro number 6 into 10 to the power of 23. So it is nothing but again 6 into 10 to the power of 21. Okay. This many molecules are adsorbed. So for each molecule, what is the area that is? Total area was available was this much only. So what is for 6 into 10 to the power of 21 molecules, we have 1.5 into 10 to the power of 2 meter square area. What should be there for each one molecule? So it is 1.5 into 10 to the power of 2 by 6 into 10 to the power of 21. Okay. So if you solve it, how much you will see? This is 150. You can try this easily. Okay. So what is the value of P you will get? Now coming to the next. Vessel 1 contains W2 grams of non-volatile solute X dissolved in W1 grams of water. And vessel 2 contains W2 grams of another non-volatile solute Y dissolved in same amount of water. Both vessels are at same temperature and pressure. Then what is the molecular mass of X is 80% of Y. Then Vanta factor of X is 1.2 times of Y. Then he is asking elevation in the boiling point of vessel 1 to vessel 2. Simple applications only, direct applications only. Let us see with vessel 1. What do you write? Delta TB. Delta TB of this. KB, you write KB only. Then we use just basic molality application. W2 grams of this, molecular weight of X. Molecular weight of X is 80% of Y. So that you can directly replace this with Y itself. That is 0.8 of My into 1 by or 1000 you can use by W1. Here into Vanta factor of X. What is Vanta factor of X is 1.2 times of Y. Means 1.2. That is, you can take 1. So for vessel 2, what is delta TB? So let us say this is delta TB prime, KB into how much weight we have taken? W2 grams by This is also W2. My into 1000 by W1, weight of solvent, into 1. Then ratio between these two. So delta TB by vessel 1 to vessel 2 only. Delta TB by delta TB prime. KB, W1, W2, everything gets cancelled. 1000 will go. So only what we left is only 12 by 8. That's it. Okay. So it is how many times? Into 100. Percentage is asked. So 12 by 8 into 100. Clear? So you will get around, this is, 150% you will see. Okay? Next. A double stranded DNA, one strand is given like this. Then the amount of energy required to split the double strand into two single, means two completely separate. And average energy for hydrogen bond of A and T base, G and C base pair, A and U base pair. So in DNA, AT base, in DNA this AT base pair only exists, GC pair base. In RNA you will see AU, uracil exists instead of thymine. But between A and T double bond exists. Between A and T double bond exists. Between G and C triple bond exists. So means we are completely breaking this double bond and triple bonds. So how many you will see? How many AT? 1, 2, 3, 4, 5, 6, 7. 7 AT are there. So 7 into. Double bond you have to break. 2 into. Average energy for each one, 1 plus. Then triple bond between G and C. How many GC? 1, 2, 3, 4. With the next one. 1, 2, 3, 4, 5 and 6. So 6 into. Then 3 into 1.5. Okay. So this is 14. This is 3 by 2 you can write, suppose. Then this is 3, so that it is 27, so that it is 41. Okay. (41 kilocalories). Anyhow, we require in kilocalories. Now, a sample initially contains only uranium-238. Then with the time, the sum of the uranium-238 is converted into lead-206. The rest remains undisintegrated. When the age of the sample is 5 into 10 to the power of 8, the ratio of lead-206 to mass, ratio of mass of lead-206 to uranium-238 is 7. What is the value of P? So we already say uranium dating exists, and whatever the lead we are getting is only from uranium. So whatever the lead that exists now is only because of the uranium which is there. So the number of moles of lead will be equal to number of moles of uranium which has to be there. So whatever it is, we just use the decay constant application. So half-life period is there. So 0.693 by T half, 4.5 into 10 to the power of 9 is equal to 2.303 first order reactions. Then the ERC is P into 10 to the power of 8. Then log of how many moles of lead may be there. Lead to uranium is 7:1. Maybe lead is 7 moles are there, 7 grams are there. So 7 by 206 moles exist, plus this will be the moles which will be added to the uranium, which is the initial. So 1 by 238 moles are there, by 1 by 238. So the number of moles of uranium left, number of moles of uranium initially present will be nothing but a number of moles of uranium which is there plus number of moles of lead which is formed, which are also forming from the uranium only. So the total number of moles of uranium will be moles of lead plus moles of uranium, direct applications, by uranium which is left. So if you solve it, you will get some value of P. Direct application, but only basic calculations exist. Next. So CO, CN4, 4 minus. So which are among these complexes totally tetrahedral geometry. This CO, CN4, 4 minus. Cobalt is in +1 state. That means it will have 4s1, 3d7 configuration. Since cyanide is a strong ligand, then it should be like 4s electron also enters into this. This will become 3d8 configuration. So with the 3d8 configuration, with 4, cyanide is a strong ligand, so it will have square planar geometry. Okay. Next, this one CO, 3NO. This is an exceptional condition actually. Cobalt will have -1 oxidation state and NO will be plus. Carbon monoxide is 0. So cobalt is in negative state, will have 28 electrons. But carbon monoxide is strong ligand, means it is 4s2, 3d8 configuration. But s electrons also will enter into D because of the strong ligand. So that all the D orbitals are completely filled. So that it will become tetrahedral. Like cyanide type complexes we have seen. Then xenon tetrafluoride already there in first paper. It is square planar, not tetrahedral. PCl4 plus tetrahedral. So PCl4 is tetrahedral. This is tetrahedral. All platinum and palladium complexes are square planar complexes. ICl4, this is again square planar. Like already we have 2 lone pairs, 4 bond pairs. Then copper, this complex is again, copper is in +1, Cu, CN4, 3 minus. So copper is in +1, means D10 configuration. So that it is sp3. Then phosphorus is anyhow directly tetrahedral. Okay. So these are the 4. P4, this complex, this P4Cl, this is also complex, that is again another complex. 4 species. Okay. Next. Our organic compound P having the molecular formula C6H6O3 gives ferric chloride test does not have intramolecular hydrogen bonding, means it is not at 1-2 positions mostly. Benzene ring may be related, C6H6 is there, unsaturation is more, and ferric chloride test means it should be like a phenol type. Then compound P reacts with 3 equivalents of this will form oxime. Then the treatment of P with excess of methylene, methyl iodide in presence of KOH produces compound R as major product. Then the reaction of R with excess of isobutyl magnesium bromide and a treatment with H3O plus will form S. Then what is the number of methyl groups that exist? So your P has to be maybe like this, which is giving OH, OH, OH. Because O3 are there. And if it is at meta position, it cannot form hydrogen bonding. Then next, this will have a resonance structure where it can exist in C double bond O, C double bond O, and C double bond O. Because he says There is 3 equivalents of hydroxylamine is used to form oxide. So 3 C double bond O's exist, so that 3 moles of NH2OH will form oxides. Double bond NOH, double bond NOH, like this. But the reaction of this methyl iodide with KOH is, if you react these are the compounds with excess of methyl iodide with KOH is, these are alpha hydrogens. So excess of methyl iodide if you use in presence of alkali, they can be replaced by CH3. Even this is taken, this will resonate, will convert into carbon with negative charge. So the addition reaction takes place between carbon and carbon can react and form the stronger bond. So this will convert into like this. All will be replaced by methyl groups like this. Now, if you are reacting this one, which is R, with isobutyl magnesium bromide. So isobutyl is CH3, CH3 and CH2, MgBr. So it can add here. So finally you may see this. Here, what is our S? OH, C, H, CH3, 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 OH, same, CH, CH3, then this is also again CH2, CH2, this is again CH2, CH2, this is OH again, like this. Okay. So how many total number of methyl groups exist? That is 1, 2, 3, 4. So totally again same numbering. 4 here, 4 here. So totally it will be 12. Okay. Next. Organic compound P with molecular formula paragraph type. That's it. Paragraph type. Decolorizes bromine water, means it should have unsaturation. And you should, if you say, suppose this is directly, you see C9H18, oxygen is there. So the double bond should be there between carbon and carbon maybe. Because if carbon and oxygen is there, only 1 degree of unsaturation is there in that compound. Then reacts and shows positive iodoform test. Then P ozonolysis followed by treatment with hydrogen peroxide. So oxidative ozonolysis, Q and R. Then compound Q will show positive iodoform test. Compound R will not show positive iodoform test. But Q and R are treated with PCC. So when PCC there must be alcohols. There may be an alcohol groups. So this PCC reaction confirms there is alcohol type. But they are heated, suppose they are giving S and T, then both S and T will show positive iodoform test. And the copolymerization of this 500 moles of Q and 500 moles of R will form a single acyclic copolymer U. What is the number of oxygen atoms in S and T? So if you just see this basic thing, this has only 1 degree of unsaturation. So it should not be between carbon and oxygens. Then oxidative ozonolysis is forming on compounds. But among that, one is giving iodoform test, another will not give. But both is oxidized, then heated will give S and T, both will give iodoform test. So the basic application with this is, you may have, let us say, a compound C double bond C. Then he is saying there is first initial compound itself is giving hydroform test. Means there may be last with the CH3, because already we are saying PCC reaction exists, there is OH group in the compound itself. So that it is having CH, OH and CH3 maybe like this. Maybe you can try the things only. Then the other side you can have remaining carbons like this. CH2, CH2, maybe some OH group exist. So CH, somewhere OH groups exist. So if you just and try the reactions, you will get only with this possible case all these reactions. So what is that possible reactions is, if you take C double bond C, CH2, CHOH, because there is one more thing which is on heating, S and T we are getting the means compounds on oxidation. When you are heating, we are getting both the compounds, we are getting S and T, which can give iodoform test. Means there must be some C double bond O CH3 finally. So that oxidative ozonolysis is there, acid we are getting. So it should be like a beta keto type acid. When it is heated, it will convert into normal ketones maybe. So that is an idea. So that CH, C to H, so that it is beta keto acid type. CH, then CH2, CHOH, again beta keto acid type. Then remaining carbons. So how many at this end and at this? 1, 2, 3, 4. This is 5, 6, 7. So we have C9. So it should be C2H5. Because only unsaturation that is there here. So this has to be our P. When this is done, ozonolysis and hydrogen peroxide, it will form C2H5, CHOH, CH2COOH plus COOH, CH2, CHOH, CH3. Then he says one among them is giving iodoform test. That can give iodoform test, but this cannot give iodoform test. That is, while the compound Q will give positive iodoform test, R will not give iodoform test. So that this is our Q, this is our R. Later it is treated with PCC. Both are treated with PCC. So that they will convert into or simultaneously heated. So this alcohol group converts into keto. Keto acid will convert into CH3, C2H5, C2H5, C double bond O, alcohol was converted to ketone with PCC. Then CH2COO, anyhow this CO2 will be lost. So it is converted into CH3. Then this is again also same. This is converted to C double bond O, acid, beta keto acid. Then it will convert into CH3, C double bond O, CH3. So S and T. Clear? What are question is, how many oxygen atoms there in S and T? Total. O in this, O in this. So it will be only 2. Only 2 exist. Okay. Then polymerization of Q. Another question is also there, continuation to this. 500 moles of Q and 500 moles of R. So 500 moles of this and 500 moles of this, Q and R, because it is alcohol and acid, alcohol and acids. So it is already poly, beta, hydroxy, PHBV, which is there in our polymers chapter. So there's the same thing only. Actually, based on that, actually this question was framed. So what is this one? When this compound and these compounds are treated, its alcohol group reacts with acid there. Its acid group reacts with alcohol there. And so you can write like this. So that it says C double bond O exists for this one end. Then you have CH2. You have CH, C2H5 for this. Let us write. Okay, let us proceed. Then this oxygen of this is reacting with acid of it. In C double bond O, CH2, CH, CH3 and O. So let us write all this from little bit away from here. So what is the first one we are writing for this? C double bond O of this CH2, CH, C2H5, O. Its alcohol group is reacting with acid of this. So C double bond O, CH2, CH, CH3, its O is reacting with another one. So one molecule of this, one molecule of this. 500 moles of this, 500 moles of this. So your polymer will have 500 units like this, repeated units. But at the terminal ends you will have alcohol group in this. In this terminal end will have acid group in this. So there is no water loss. So this one you have to multiply with 500 times. Molecular weight of this chain, repeated chain. So the ends you should actually consider 500 molecules this, 500 molecules of that. But its OH group at the last, its COOH group at the last should exist free. So there is no water loss. So in this H should exist, in this OH should exist. So after repeating this molecular weight, means if you take this molecular weight mass of this, all this chain repeated unit as M into 500 plus 18 you have to add. Okay, that thing you if you do it, that will be your next. What is the molecular mass of U? Okay, the next. Potassium iodide is added to an aqueous solution of potassium ferrocyanide. Reversible reaction observed in the complex is formed. In the strong acidic medium, equilibrium shifts towards P. Then addition of zinc chloride, P slightly acidic medium changes into sparingly soluble complex. So this is the basic standard questions which are there in qualitative analysis. Ki reaction with K3 FeCN6. So anyhow, iodine is a reducing agent. It reduces ferri into ferro. So you will get K4 FeCN6 plus I2. But if Ki is added in excess, then the reaction is this Ki plus I2 reacts and forms Ki3. So there are two things in this. If you don't take Ki in excess, if you take in limited amounts itself, balancing this reaction, its N factor was 1, its N factor is 2. Or anyhow, this N factor is also 1. I minus changes into I2, but if you write 2, so the total number of electron in this is 2, in this is 1. so that this becomes coefficient wise. This is 2, this is 1. So that if you balance it, FeCN6, Ki2, potassium, K4, this also should become, its N factor was 1, so 1 it comes here, 2 it comes here. So that this becomes now 6 plus 2, 8, so that it becomes 2. So that 2 moles of this, so number of moles of potassium iodide required to produce 2 moles of P. So what was P is this complex. So for 2 moles of the complex to form 2 moles of Ki is required. But if you just use the other thing, that is Ki plus I2 reaction, then it forms Ki3. Iodine is absorbing I minus. Then you require 1 more mole. So for this, usually we take normally 2. Maybe if extra Ki is used, R3. Okay. Next, the reaction of addition of zinc, what is it forms? So sparingly soluble between this product which was formed from the reaction P, that is K4 FeCN6. It is directly there with ZnCl2 tests. For zinc ion test, it forms now this K2 Zn3 FeCN6 2 times. This type of complex it forms, which is a white precipitate, and it is sparingly soluble because potassium ion exists and zinc ion exists, so that it is sparingly soluble. So the number of zinc that exists here is 3. Okay. So this is, I think, the last question for us in the paper 2 even. Okay.